Internet. I am Sarandalot, and today what I'm going to be doing is making a little tutorial video on how to write a script in Python in order to connect the direction in which a sun lamp is pointing and the direction in which the sun in a sky texture is pointing. Now, if you know what I'm talking about, and you've experienced the difficulty, then you know that it's a huge pain to try and line those two things up. But for anyone who doesn't know exactly what I'm talking about, then allow me to explain. Actually, allow me to demonstrate. Because what I'll do is I'll have a default scene right here. I'll change this to a sun. Change it to cycles. Actually, hit and use nodes. Just adjust the size because I like it better like that. So now we have to put a rendered view here. So we have a sun and cycles, but that's boring, right? Who likes just a gray background? So I'm going to go to the World tab here, hit Use Nodes on the background and the surface, have a background, and where it says color, I'm going to change it to a sky texture. Now this looks a little bit more exciting. You can see a bit of a sun up there. What I'm going to do is just change my preferences for these settings are set the ground albedo to 100, set the turbidity to 6, just makes the sun much more evident, and set the strength to 2. So we've got a nice looking thing there. We've got a nice looking background as well. I mean, it's weird because we don't have a ground plane, but anyways, you understand the general point. Now, here's the problem. Go back to our solid view, see that our sun was not pointing straight down. It's pointing at like a weird angle over here, right? But the angle of the sun in the sky texture is right up in the top of the sky. So how do we change that? Well, the way I used to do this is I'd select the sun lamp, hit period on my numpad, and then hit Control-Shift-7 in order to be facing directly into the sun, go into my rendered view, and then grab the ball over here and like adjust it until I'm like, okay, a little bit more, a little bit, that's about right. So there we go. Now it would be about right. So if I have my cube over here, let me just readjust. There we go. So now what I'll do is that I'm just gonna make a little UV sphere. Change that modifier, smooth it a lot, and give it a glossy material. Glossy. Where is it? There we go. The roughness of like 0.05. And now when we set this to rendered mode, we can see that we can see where the sun lamp is, and we can see where the sky texture is, and I got it pretty good. I got it pretty well there. But I mean, it's hard to get it exactly like that, right? I mean, it's not the easiest thing. I mean, sometimes as well, like you have your sun pointing like really low in the sky, and let's see, hit 0, Control-Shift-7, and this is just, it's a pain, right? Because then like you're completely disoriented as well. Like how do I, like where's the right place for this? Like where I can't tell. Like is the sun here, or like is the sun, what's going on, right? So how am I supposed to know exactly where to put this thing? Because and like look at this. It's There you go. See, and it's not exactly in the right place. You can tell the sky texture is over here, and the sun that I ended up putting is like way off. So it looks weird. I mean, why would you want to have this, right? Well, have I got the solution for you? Basically, what we're going to do is we're going to write a small little Python, once I get out of this, we're going to write a small little Python script that will connect the direction in which the sun is shining to the direction in which the sky texture is pointing. So what I'm going to do is just separate this a little bit, change this to my text editor, and create a new text block. I'll call it something like sun sky. Whatever, doesn't matter if it's internal. And what we're going to start by doing is we're going to import three things. First thing we're going to import is the blended Python, BPY. Let me just turn on all these things. We're going to import math utils. We're going to import math. Now, first thing that we're going to want to do is get the angle that our sun lamp is shining at. So we're going to call it something more distinctive than this. We're going to call it like sun lamp. There we go. Much better. So in order to do that, let's say we have to do the x, y, and z angle of this sun lamp. So let's say x angle is equal to bpy dot data dot objects, and then in square brackets in single quotes we have sun lamp, because that's the name of our thing, dot rotation underscore Euler or Euler, however you want to say it, and then we're going to have 0 because it's an array. So this is for the x angle. That gets the x rotation of our lamp. So basically, it's getting this this value here in radians, because everything works in radians right now. So I'm going to copy this 2 times. The second one's going to be the y angle, and it's going to be index 1, and the third one's going to be the z angle, and it's going to be index 2. That's the first thing we've got. Now we've got x angle, y angle, and z angle, which are the orientation of this sun lamp right here. Now, what I'm going to do is I'm going to create a vector called vet is equal to math utils dot I'm hitting all sorts of T's now. Vector. Then in the parameter that you're going to pass it is one parameter, but it has three indices. So it's we're making a vector here. So the first component is going to be 0.0, comma 0.0, comma 1.0. Now it has to be, I'm not 100% sure why, but it has to be 0, 0, and 1 in order for this to work. So now we've created a vector that we will use as the vector to show where the sun is supposed to be pointing in the texture, the sky texture. Now what we have to do is create 3 matrices for rotating the object in 3D space. The reason we have to do this is because we're rotating, we're trying to find the vector components of an object that has been rotated around 3 axes, and in order to do that we need to have three rotation matrices which we will multiply the vector by in order to find out exactly what the final components are supposed to be after the rotation. That's why we made this in the first place, because it's kind of an arbitrary vector just to start off with, but it is the default of the starting vector components for the sky texture, so it's safer to keep it like that. So the first matrix we're going to make is the x matrix, rotation on the x, so that's equal to math utils dot matrix. And now the matrix also has it has three main components. So we have brackets, and then we have brackets, and inside this inner pair of brackets we have three pairs of brackets here. So in the first one we're going to have 1.0, 0.0, 0.0. In the second one we're going to have 0.0 math dot cosine of the x angle. And if you're wondering where I'm getting these, it's actually it's a Wikipedia page of rotating a matrix. So here you can see to rotate on the x-axis, this is the matrix that you have to multiply the vector by. Rotating on the y, this is the one that you have to use, and rotating on z, this is the one that you have to use. So this is basically what I'm following just now. I have it open in the other screen. So I'll just continue. I'll link this in the description in case you want to follow it yourself. But I mean, I'll write it all out here. So we had the math.cosine of cos of the x angle, and then after that we have negative math dot sine of the x angle. And now for the last one, we have 0.0, comma, math dot sine of x angle, and then math dot cosine of x angle. There should be 4 brackets after here, yeah, just to make sure. Alright, perfect. So now we have to do the y and the z axis. So the y matrix is equal to math utils dot matrix here, there, and there, there, and just to make this easier, I'm just gonna copy this while we have it, paste it down here, turn it into the z matrix as well, because it's the same thing to start off with. So now for the first section of the y matrix, we have math dot cosine of the y angle now, because we're working on the y-axis, and then 0.0, and then math dot sine of the y angle. Second section, we have 0.0, 1.0, 0.0. In the third section, we have negative math dot sine of the y angle, and then 0.0, and then math dot cosine, not cod, we're not touching fish here, of the y angle. Perfect. Now for the third one, for the z-axis, it's math dot cosine of the z angle, z, however you want to say it. Negative math dot sine of z angle, and then 0.0 for the second section. We have math dot sine z angle, math dot cosine of the z angle, and then 0.0. Then for the third section, we have 0.0, 0.0, and 1.0. There we go, 1.00. So now we have our 3 matrices there. What we have to do now is multiply our vector by each one in order. So what we're going to do is say the vector is equal to, and you can multiply a vector by a matrix simply by multiplying this. It used to be that you had to use a function in either the vector or the matrix class to do this, but now you don't. You can actually just print, you can actually just type like what I'm doing here. So vector equals the x matrix times that vector. And that's all you have to do. And you can just say the vector equals the y matrix times the vector, and the vector is now equal to the z matrix times that vector. So we're modifying it each time now and multiplying it by the matrix in order to calculate what the components are supposed to be depending on the rotation, which we determined from the original sun lamp rotation here. I wrote vac here, vacuums. For VCC, there we go. It's important that you write the vector is equal to the x matrix times the vector and not the vector times the x matrix, because if you put the vector first, the calculation gets screwed up, so you have to put the matrix first and multiply the matrix by the vector. It's a weird thing I think it's to do with how it's calculated. So that's that part. Now we have a vector that is the correct vector in which the sun texture is supposed to be signed, but we have to set that first. So in order to access that, what we have to do is basically type bpy dot data dot worlds, and then the world, which is called world dot node tree dot nodes, and then the sky texture, as we come over here, we can see it's called sky texture. So we put that in here, sky texture, and then the property of this is called sun direction dot sun underscore direction. And then this is a vector already, and it's going to be equal to the vector that we modified by multiplying it by the matrices, and that is all that you have to do. So I'm going to save that, and we'll see here. To make sure it works. There we go. I got no errors. So basically what I'm going to do is split this a little bit and change this one to the rendered view, so we can see here. Alright, so we have that now. Now, up here I'm going to rotate this a bit so you can see where the sun lamp is now, which is this bright dot here. And where the sun texture is now. As soon as I hit run script though, boom, right in the right place, exactly in the right place. So it's such an easy way to do this, and it's incredibly convenient. It actually doesn't take too much work either. It's just calculating the rotation by multiplying the vector by a matrix. So there you go. It's really easy. Let's see. Put the sun lamp down. That's not going to work if it's below the horizon. It's just going to look weird. But let's say we put it down here. Run the script. There we go. Very nice. We've got a nice looking. Oh, I'm inside the. Oh, there we go. There we go. We've got a nice looking scene here now. Anyways, there you have it. I think it's a very, very convenient thing. Didn't take too much time to figure it out, but it's something that you can make a lot of use of, especially if you like using sky textures, like I do. So thanks a lot for watching. I hope you enjoyed the video, and yeah, I hope you found this very useful.